certain wording that I want, and the best way to do it is at first for you guys to fill in the blanks so you can figure out, okay, he wants this wording every single time. So number one, all I have here is a reflection. That's it, reflection. If you reflect any type of figure, does the size change? Does the shape change? No, so it makes sense. If I'm just going to do a plain reflection, I don't care what line I'm going to reflect over, it's going to remain congruent to the original, right? Everyone agrees? All right, so here's the wording I need by filling in the blanks now. Reflections are, we have a term for it. This doesn't change size or shape. Those are types of rigid motions. Yep, so reflections are rigid motions, and I'll help you with the rest here, that preserve distance. Now, I know a lot of you, when I say that word, you think of the formula automatically, and I don't blame you. What I mean by distance is side length. Okay, it preserves the side length. The side length does not change, but we say distance, and it also preserves the angle measure. So instead of doing side, angle, side, those 5 methods that I showed you earlier on in the year, we just say, hey, it's a reflection, distance and angle measurement stays the same. Therefore, the 2 triangles ABC and A prime, B prime, C prime are congruent. I know it's been a while since we wrote that symbol. And that's basically what we're going to write. But you got to figure out what we're doing. I told you we were doing reflections here. Now we go to number 2. I have ABC graphed onto XYZ. Why are they congruent? So now it's on to you, and this is why I said you need to have this skill to be successful today. Can you get that mapped onto XYZ for me right now? All right, you know how I'm going to start it before I let you take off. ABC, what direction are we looking here for orientation? ABC, clockwise, and then match it up. XYZ also going clockwise, so probably not a reflection involved. I will let you know it's only one transformation, though. All right, this is not a sequence. It's only one transformation that will do ABC onto XYZ.
Will there always only be one?
No, could be 2. We're going to do 1 in a second, too. And you're not going to know what it is either. Like, you know it's only 1 based on the blanks I have here, but you're not going to, you got to look for yourself and say, all right, can I do this in 1 move, or am I going to have to do multiple moves? That's going to be on you guys. All right, so real quickly, and then I'll call on somebody. How do I map those triangles on top of each other using 1 transformation only? And please remember from yesterday, be specific. I don't want to hear the word translation. If it's a translation, tell me up, down, left, and right, and how many. So get specific for me. So yes, in a nutshell, we are doing proofs with transformations. Proving triangles congruent using transformations instead. All right, what do you think here? What's your transformation? Be specific for me. Oh, there we go. Gianna, what are you thinking? Good job. All right, so transformation is a rotation of 180 degrees, and I'm going to even get more picky with you. No, look at you. Yeah. About 0, 0. Or the origin you can write. Good job. Got to give me a center of rotation because you guys found out yesterday there's other centers I could rotate around. All right, now here we go. And here's the rest of the, I know it's going to sound like a broken record today, but this is what we need. Since rotations, that's what you told me we're doing, are rigid motions. And here you go. They preserve distance and angle measure. That's why they're congruent. Distance and angle, sides and angles don't change. Thus, triangle ABC. Be careful here because we're not doing primes. We're doing XYZ. All right, Ian just asked, hey, is it always going to be 1? And the answer is no. Here's an example of you're going to need multiple ones. All right, to get the job done. 1 won't do it. I don't think anyway, but I don't think 1 will do it. So you're going to need 2 transformations. Oh, look at here. Whoa, whoa. ABC, we got a little clockwise, but look at A prime, B prime, C prime. What do we got going on there? Counterclockwise over here. Oh, we know what's going to be involved, I hope. All right, go ahead. Get them on top of each other. Somebody better be telling me a reflection's one of the two. Orientation changed. I'm just noticing something with this one too. All right, got your two transformations rolling. All right, describe to me how I can move them. Describe to me here. Ooh, Olivia, hello.
Reflection on the Y and then translation down 3.
Love it. Great job. Perfect. That's one I had. Yep. So ABC undergoes a reflection over or in, either one, over the y-axis, and a translation. Now, how you describe it, we could write down 3. Take a look. We could also go write it in vector. I always do that. Write it in vector. Or we could do the capital T. Whatever gets the job done that says you're going down 3. Which, before I fill in the rest, anybody know here? Put these two together. What is this? Is it a glide reflection? Did I slide parallel to the line I reflected over? Yeah, we reflected over the y-axis and went down 3. This is a glide reflection. Yeah, look at us. All right, anyway, since reflections and translations are both rigid motions, and we know the rest here. They preserve distance and angle measure. Thus, triangle ABC congruent to A prime B prime C. Okay. That's great that you guys are memorizing what I want to say here with the blanks, but we understand why they're congruent. All right, because all these transformations we're doing, no matter if we're doing it over a line, sliding it, rotating it, it doesn't change the size or the shape, which is what we're saying here. Go ahead, Steve.
Does it matter if the reflection across or the wax?
Nope. Skip the pointer. I just want to know it's a reflection and where you're reflecting. However you get that point across, it's up to you. All right, ready for the blanks to go bye-bye. The blanks are leaving, which is mainly will be the case here. Well, also, I only gave you guys an image. I only gave you a pre-image. Where's the image to compare it to so I can know what the rule is? Oh, you're going to find the image. So this is a little bit different than the problems we've done already today. You're going to create the image using the rules up here, and then you're going to tell me in part B why they're congruent. All right, so congratulations, you don't have to find the rule, but you're going to apply the rule, which is translate it 5 right up 2, and then we're going to reflect it over this crazy line y equals 0, and what the heck does that mean? All right, so let's first do the translation. 5 units right, 2 units up. Let's graph it. 1, 2, 3, 4, 5, 2 units up. And it looks like we can call this A prime because it looks like they're going to call this A double prime, B double prime, C double prime. So we don't have to leave this one blank, the translated one. 1, 2, 3, 4, 5, 2. right, got my translated one done. And I feel uncomfortable and awkward. Not anything new, but y equals 0. Not a big fan of that right there. I don't want to, I know I could go on numworks and graph it. Wait a second. I'm trying to put stuff together that I learned from this unit. Y equals any number was what type of line? Okay, horizontal. Now this just happens to be a horizontal line through 0. This is just a fancy name of what? Reflected over the x-axis. Yeah, y equals 0. Horizontal line going through 0. I shouldn't say fancy. I should say an honors way of writing the x-axis, huh? All right, so let's reflect it over the x-axis. It doesn't say to state, right? It just says graph and label, no state. Okay. 1, 2, 3. This is my favorite part of the day right now. Not writing this, but you'll see when it comes up. All right, how are we going to first tell me what you did? You don't need to get specific because we already know the specifics here were told to us. So we could just write, we did translations, right? Translations and reflections. Are, just dropping the blanks, guys. Just dropping the blanks. Are rigid motions. Which preserve distance and angle measure. All right, now here's where we're gonna have a little fun here today. Because you know me, I can't do math 40 some minutes straight here. I have been using the word thus in every single problem. Can we get more creative? Can we get more creative here? Other words I could use in place of thus. Here we go. What else could I use here? Thus.
Therefore.
Therefore. Awesome. Matt?
I'm going to say
Therefore. Great one you can put. Thus. Therefore. Come on.
This implies.
Oh, okay. This implies. That's a brand new one. Makes sense to me. This implies. There's a lot more out there. Come on. We're going to go through all of them too.
Like, this action causes.
That's too much to write. That's too much to write. Come on. What else do we have?
Because of this.
Because of it? Come on. I've only got therefore and thus. So, okay. Right to the point. 2 letters. I'm done. Nothing else? Hence. Henceforth. Pretty good. I got a trump card. I got a trump card here, a clincher, a boss one here. Nothing else you want to put before we do synonyms? Nothing? Okay. This has already been searched. Consequently, accordingly, there's hence. Thusly, where's my go-to? Where's the boss one? There it is. Ergo. Anybody know? Never heard of that one? Ergo? Yeah? No? Meaning therefore? Nothing else? What else do we have here? Let's go to the thesaurus. Thus, so, that's the strongest match. Way to go. There you go. Hence, thusly, along the lines, to such a degree. Add a little math in there. Mr. Claremont, how we doing?
Ergo is one of my favorites.
It's the best one. We're saying, you end your statement with thus. We can do something a little better than that.
Therefore.
Yep. See, there we go. Hence.
3 dots.
Henceforth. Yep. Like so.
Wait.
There we go. There it is right there. Not bad, huh? Or you could do the remix version. All right, so you guys pick. I do not want to see thus anymore. We've gone through all of that. Find something better.
Yeah, everybody else is
All right,
doing it.
good. I'm going ergo. Triangle ABC, congruent to the double prime. There was a Latin one too I used to use years ago. QED, was it? Quada est demonstrata, I believe. If you really want to go hardcore. This might be playing with fire. Quada erat demonstrata, which was to be demonstrated. So we could go QED as well. There you go. Do they have a voice for that one? I just know how to pronounce that. Erat demonstratum. What is to be demonstrated? QED voice. I'm playing with fire.
Can you just put in the like Google Translate? Just copy the meaning and put it in Google Translate.
Okay, you guys got it. Oh, I got to do the whole Latin, right? There we go. There we go. Impress some people if you haven't had lunch yet. So if you're arguing with somebody and you end up being right, you just finish it off with a, that's what I thought, you know? All right, there we go. All right, you can start your work.